My name is Y. Clark, and I'll be teaching you about functions. A function is any problem that results from one dependent variable, such as x, resulting in one and only one y variable, which is the independent factor. To find certain things in functions like the x-intercept, y-intercept, horizontal asymptote, and vertical asymptote, you have to do different things. To find the x-intercept, you first have to set y equal to 0. Then, you want to get rid of the denominator by means of multiplication. Ultimately, you result in 0 equals x minus 1. Isolate the variable by adding 1 to both sides, and you have the x-intercept as x equals 1. You want to then plot this on your graph. Next, let's find the y-intercept. To find the y-intercept, first set x equal to 0. So y equals, parentheses, 0 minus 1, parentheses, over 0 plus 3, parentheses, 0 minus 4. Then simplify. It turns out to be negative 1 over negative 12. The answer is y-intercept equals 1/12. You want to plot that again on your graph and go to the next step. Next, we'll go to horizontal asymptotes. Use only the variables for this, so it's x over x squared. And this qualifies as case 2, which because the bottom is greater than the top. So the horizontal asymptote is equal to 0, but it can be crossed, unlike the vertical asymptote. Next, we use a vertical asymptote. You find by using the zeros of the denominator. So it's x plus 3, x minus 4, both in parentheses, equals 0. So x equals negative 3 and 4. These are your vertical asymptotes. You want to plot them on your graph using dotted lines. And now you have a graphed function.
My name's Eric, and I'll be doing transformations for you. Okay, so the formula for transformations is y equals an a, parentheses b, parentheses x plus c, double parentheses, plus d. Some examples of the a would be just like, oh my bad, I forgot to put something there. Would be just having like a negative in front of the x, or a 3, or a 4, whatever you want. Example of b would be inside the parentheses, there would be a 3, or a negative, or whatever. A c, an example of a c would be x plus 3 inside the parentheses. And then an example of a d is x and then after the parentheses plus 3. Okay, so to figure this kind of stuff out, you have a table. And here's the table for you. A, B, D, C. The B and C's act on the X's in the tables, this side. And they act inversely. The A and D act on the Y's, and they act normally. The A and the B's scale it, and the D and the C shift. So shifting would be like moving it left and right. Scaling it would be moving it up and down. Okay. Here's a simple example of a transformation. Y equals negative 2x. The negative is the A, and the 2 is the B. So when you look at the table here, you're going to have a base, table of what y equals x squared is. And this is what it is. Negative 3 would be 9. Negative 2 would be 4 because you would put it into the x squared equation. Yeah. So you get this table, and then what you do is you take it and you apply this equation into this table. So since this is a negative, it pretty much just switches the negatives to positives and these positives to negatives, as you see here. The B acts inversely, so what it does is it pretty much, since this is multiplication, it's going to act as division instead. So the 9 is going to turn into a 4.5 because 9 over 2 is equal to 4.5. The 4 is going to turn into a 2. The 1 is going to be a 1/2, and so on down the equation. Once you get the whole table filled out, what you're going to do is you're just going to apply it to a graph, and that's going to be your transformation. So, yeah, that's pretty much transformations for you. Hope you learned something. Go.
Hello, I'm Sarah Offenklaus, and today I'll be teaching you about inverse functions.
Beautiful.
Essentially what you're doing with an inverse function is you're going to be switching the x and the y's. So say these are your plots up here for your original graph. After your inverse function, they'll turn into these. You just switch the x and the y's. So how to do an inverse function, one may ask? Well, if you start out with this equation, all you have to do is switch the x and the y and solve for y again. So what you would do, simple algebra. And this is your inverse function for the original equation. They're just basically going to undo each other. When you graph an inverse function, so if you have your original function right here, it's just going to be mirrored over the opposite axis. So this is your original one, and after your inverse, it's just going to mirror it over the other axis. Thank you.